Sharing the knowledge is a charity of knowledge that constitutes the base of a beautiful life. Very good morning to one and all present here. I welcome all the participants for the Tech Series 4.24 on From Gas to Green, the Electric Vehicle Revolution, conducted by Triply Department, SA Engineering College. SA Engineering College is an autonomous institution affiliated to an university accredited by NAC and NBA. The college has 26 years of excellence in the field of education, providing the students with the best opportunities to excel in the core engineering courses such as EEE, EC, Mechanical, Civil, CSE, IT, to the latest outgrowing courses such as AIDS, AML, VLSI, CSBS, Cybersecurity, along with 6 PG programs. We are very proud to announce that SA Engineering College has secured third position in placements among the top private engineering institutions in Tamil Nadu. We also have secured fourth position in all aspects among the top private engineering institutions in Tamil Nadu and Puducherry. Triply Department is one of the core departments in the field of engineering. We are happy to conduct this tech series by our alumni, Mr. M. Kabilan, a very good and outstanding student of Triply Department, who has added more proud moments during his education tenure in our college. I would like to introduce our guest of the day, Mr. M. Kabilan, engineer, L&T Technology Services, Chennai. He has completed his BE Triple in 2020 and M.Tech Power Systems Engineering in 2022. He has good knowledge and exposure in C, C++, MATLAB, Android, Python, Java, and Verilog. He has worked in different projects using hybrid MPPT for PV systems, adaptive neurofuzzy inference, and neural network, design of EV engine, BMW automation, and many more. Now, I welcome our guest, Mr. M. Kabilan. I'm happy to have you today in our midst after long years, Kabilan. Uh, Revolution happens every day in the history of electric car ever since 1834. Now, we would like to see the latest revolution in electric vehicle through your experience, Kabilan. Once again, I welcome you, Kabilan. You can now start sharing the knowledge. Thank you, Kabilan.
So, thank you so much, ma'am. That was a wonderful introduction. So, good morning, everyone. Happy to see this moment just joined today. So, I'm just a guy who has very less knowledge. As ma'am said, too much knowledge. So, I have very few knowledges. I have recently passed out, so I'm not the guy who studies well. Ma'am said I studied. No, I'm just a guy who knows this knowledge. I have some practical experience that was based in India. So we'll just directly move into the session and just present my screen. Screen is split. So, so today, as the title suggests, uh, like gas to green and electric vehicle revolution. So there has been a recent trends for electric vehicle. As you know, it's gaining popularity, maybe due to the atmospheric environmental changes as we have known. But there are few drawbacks with related to EV. So there is too much drawbacks. We'll discuss about that. So generally, as an electric vehicle, so this is a table of contents which I'm going to share with you today. So bear with me for 1 hour. The session is boring. Please let me know through comments. Actually, soon. Like if session is too boring, just give me a like text me like give in the chat. I'll just look into it. So like I'll try to make the session as interactive as possible to not let you guys sleep because I'm just saying to myself like, if session is post bored, even I'll sleep. I'm also a guy who came from your side, so I know how that will be, how painable, how it will be paining to see a guy suddenly coming up, popping up, and saying everything new things. Just I'll say like I'll make it as crisp as possible. So today we'll see about like what is history of EV, where the EV started, and what is an electric vehicle. Like too much like what is an electric vehicle. I'll just give an intro like what are the new things are there, what are the types of it, and chargers, or how they like how electric vehicle is charged. As you know, it's not like a mobile charger something. They have specific chargers. They have standards for it, and what are connectors, like what connectors they use to charge the EV vehicle, and like in electric vehicle, what are the EV vehicles in India, what are the changes they're having in India, and what are the challenges we are facing for the electric vehicle, and what are the charging station challenges we're facing, and what are the startup companies which have recently like started in India. So EV, an electric vehicle is a vehicle which uses electric motors for propulsion, where it doesn't use a combustible engine. Instead of that, it uses a battery pack which stores energy from extra vehicular sources such as like grid, like we can grid something like that, and it will store the energy and it will give the same to the wheels, and where the wheels will start like move the vehicle. So this is the basic idea of an EV. So history of EV. As you can see, like as ma'am stated that EV started just that revolution didn't start no, it started a long time. Like the first engine was started around 1824, 1827. So from that time they were like adapting to EVs, and they were changing, like they were progressively improving, and as of now today what you see is that EV which has like improved too much. So it was started in 1900. Like there were many producers like Baker Electrics, Columbia Electrics, Detroit Electrics, and like they were having these means companies which were like producing EVs at during that time. And in 1900, you see that like 20% of the cars on the road in US were electric, which is astonishingly very high. So like as of now, we are more towards the combustible engines. Like we don't know, like it's due to that popularity, the sound. Like we love to see more muscle cars, but now EV doesn't give so much sound. Like it's a silent way of running. So EV were like popular, so it was so popular that even the president Woodrow Wilson and his Secret Service agents were touring Washington DC using these cars. So it used to run like it used to per charge it used to cover 100 to 110 kilometers. So early attempts like in 1827, Hungarian Greece started to build an electric motor. After that, it went to like 1835. Professor Branch start in university. He started at the small scale of electric car. Then Robert Anderson of Scotland invented another electric carriage, and American inventor Thomas Davenport built a toy electric locomotive. Then 1838 and so on. It's like we are seeing in higher versions of it. So like in 1900s, electric cars are more popular. But however, we see that in like as we know, Henry Ford, the guy who's like of father of like combustible engines, he started like giving too much car because of its popularity and cheap assembly. Electric cars were declined at that time. As you can see, this is an image of an 1914 Detroit electric one. So this is a Tesla car. As you know, Tesla is the one who bought that electric vehicle into this, like into like showing that it has too much powers within it, and he introduced us within this one. So electric vehicle. Why EV? Next question. Always like what, why, when, like that. Why EV? So as you know, it's a cleaner environment, better driving experience. Better driving experience in the sense like whatever power which is taken from the battery, is 100% delivered into the vehicle. You can get the power as much as possible, but not in the combustible engines. There are losses within combustible engines, like while producing energy, there is energy loss, heat loss, etc. That much losses are there. More digitally connected in the sense nowadays we can see like AI cars, which drives itself, Google cars, like that. So it is more digitally connected. Noise, less noise in the sense there is no noise. As of now, most TVs doesn't give that much noise, and higher performance. As I stated, it give the water power it is taken from the battery. It is delivered 100% to the vehicle wheels. So EV parts. These are inside an EV. These are the parts which are there. So as you can see, a charging port, a battery, a power electronic controller, a traction battery pack which is always present at the bottom of the car, and power inverter, electric traction motor, transmission, charger, and DC-DC converters. If I want, I can go more into depth into this, but it will make the session more and more like into boring session. So, if is one thing I like to say is most of the EV cars will have engines at the back. Most of the EV cars will have an engine at the back, and some cars having at the front. It depends upon their model, their version, the company standards, everything. But every car has to follow a standard called as ASIL rating. ASIL D certification is the only thing which is required for an EV car. It is a must certification. So previously, like if you see combustible car, there is ASIL rating also. American standards. As you can know, those American guys always play with the lights. They leave that place. So A and B. Previously, even in the combustible cars, you can see like some electrical parts were there. They were having ASIL A, ASIL B certification. But as of now, the standards for electric cars moved to ASIL D. ASIL D is the main certification. If the car doesn't have an ASIL D certification, they can't make into a product as of now. It should get an ASIL D certification. This ASIL D certification sets a specific barriers or standardizations which an EV car should work. Like if it's submerged in water, what will happen next? If it crashes, what should happen? Which should trigger? Which should not trigger? What should happen to the engine? These are all set in a specific standards, and to be more precise, they will say like if it if the car hits an blockage or it's met with an accident within this much second, what should activate, what should deactivate, what are the procedures to stop to make it make it make the accident more worse. So these are the standards which are very important for an EV car manufacturing. So types of EV. As you can see, like there are two EV. Everyone knows the common word electric vehicle, but there are some specific types for it. Battery electric vehicle, hybrid electric vehicle, plug-in electric, plug-in hybrid electric vehicle, fuel cell electric vehicle. These are the major classification. Sub-classification for hybrid electric vehicle is mild hybrid electric vehicle and full hybrid electric vehicle. So battery electric vehicle. This is the most common EV, which are like gaining popularity as of now. As the name indicates, battery electric vehicle, which is uses a battery technology to run the car. As you can see from the image, the batteries gets charged. From that, it gives power to the electric motor, which in turn runs the uh, car. So, example for battery electric vehicle, as we know, is Tata Nexon, Hyundai Kona, BMW iX. These are the like some examples of battery electric vehicle. And hybrid electric vehicle, which is known as like there are two types of, as I said, mild hybrid, fully hybrid vehicle. So in hybrid electric vehicle, as you can see from the image, there is a fuel tank and a battery. As you can see here, there is a fuel tank and a battery which is there. So why hybrid electric vehicle? So hybrid electric. Sorry for that. So it uses an IC engine. So combustible engine is there, a battery pack is there, an engine is there. But what is the main thing of hybrid electric vehicle is that like this battery supports the engine. It doesn't like it doesn't run the vehicle, but it supports the engine to make the performance and efficiency more. In fuel from combustible engine, as I said, there will be too much losses like for shifting and all. To reduce the minimize shifting, Nowadays, as you can see, there is no manual shifting. It is combined. It's been changed into automatic shifting like that. For that automatic shifting kind of thing, this battery is enabled to that performance. And for this battery, as you can see, it's not charged from external sources. It is getting charged from the regenerative braking. Regenerative braking is it's a more electrical concept. I just don't want to move into more engineering perspective kind of things. I'll just keep it in minimal way. The regenerative braking, I'll just get like regenerative braking is like if the motor moves out of its revolution, it will act as a generator. It will give power. Simple. So generator will charge the battery. That battery is used to make the engine to make it a smoother performance. Example of hybrid electric vehicles are MG Hector and Suzuki Grand Vitara. So like that. And plug-in hybrid electric vehicle, which is similar to electric hybrid electric vehicle only. But the main difference is that previously stated that the battery will be charged using a regenerative braking, but here, the battery is charged from an external source. Like a normal battery electric vehicle, will connect. Will use from will use a charging port to charge the battery. And another main advantage of plug-in hybrid electric vehicle is that you can use in both modes. If you want, you can run the vehicle in for an electric car for up to the battery drains. After it drains completely, you can convert it into a fuel car and you can use the same. But the hybrid electric vehicle doesn't have that much advantage with them. So, example for plug-in hybrid electric vehicles are BMW 7 Series, Porsche, like that. Next is fuel cell electric vehicle. You might have seen a video for fuel cell electric vehicle, like a bus getting charged using hydrogen fuel tank. That's exactly what is a fuel electric vehicle. It uses hydrogen, which is having a hydrogen tank, as you can see in the image, and a fuel cell, like some chemical energy converts into electrical energy. I hate chemistry, guys, so we just pass on to that one. So hydrogen tank. From that hydrogen tank, it will get charged into the battery and it will run the motors. Main advantage is that it will charge within minutes. You just have to take a hydrogen tank from uh, a bunk or something like that. Just put it into charge. Just take it and ride. So fuel cell, for example, of fuel cell is Hyundai Nexo, Toyota Mirai, like that. So, what are the types of battery in an electric vehicle? As you can see, these are the mainly classified types of battery which are used for an EV. Lithium-ion, nickel metal, lead acid, ultra capacitors. As the table suggests, like from the table, you can get an idea like lithium-ion is more convenient because it has an easy access, energy efficient, temperature performance good, weight is somewhat less, and life cycle. And from this, we'll get to know that most of the EVs use only lithium ion for their electric vehicles. So, into session was going too much. So, if possible, in comment, can you just give me what is the company logo for the first one? Can you see my screen? So, anyone in chat, or we can skip the session and we can move on if you want. So, I'll just fast forward the sessions. Next, types of chargers. What are the chargers which are using for EV to charge the electric vehicles? So level one, which is a slow charger. These chargers are mostly found in households, and which we can the EV owner can recharge their vehicle According to the comfort and convenience, this EV charger take comparatively longer time to completely charge the vehicle. As the name indicates, it's a very slow charging. So it is mostly found in household, like within homes. If you are EV owner, if you want to install a charger, you can just go with a level 1 charger. Then level 2, which is a fast charging. Like as the name indicates, the fast charger you finding in like bunks, public places, supermarkets like that, where it is used to charge the vehicle. Uh, Almost every EV and plug-in hybrid vehicle can be charged using a Type 2 charger. I'll move on to like what is a Type 2 charger, what is that. I'll just in the upcoming sessions I'll discuss you about that. And next is a rapid charging. Name indicates like within some duration you can completely charge the vehicle and you can like take it for a drive. So this level 3 charger perhaps only for DC charge. Level 1, level 2, it will be mostly of AC type. Level 3 is of DC type to be. So like it's fast and it converts the AC incoming current into a direct current at the charging station. It generally charges an electric car up to 80% within 20 minutes and can fully charge the vehicle in an hour's time. Level 3 rapid charging is like I'll call another name where Tesla company uses. It's like supercharger. Most of the Tesla cars, it's charging as in public place charging. It's come by the supercharger, and here it depicts a charging speed for the level 1, level 2, and level 3. In level 1, the power delivered is about 1.4 kilowatt, and range added per hour is 3 to 5 miles. So, like, and the time charged to 60 kilowatt EV. It's like it's like a standard or basic set we can consider 30 to 40 hours. So for a level 1 charger to completely charge a EV, it takes about 30 to 40 hours, which is a slow charge. It takes too much amount of time. So level 2 will go. It delivered power is 3.9 to 19.2 kilowatts. Range added per hour is 12 to 80 miles, and it can charge like 2.5 to 4.5 hours. As you can see, the difference from 30 to 2.5 hours is very drastic. And level 3 is 24 to 300 kilowatt. It can range added is 75 to 1200 miles, and charge rate is 30 to 40 minutes. This itself depicts that how much we are like progressing towards EV. As you can see, this data it just indicates a battery level charge from 10% to 80%, not from 0 to 80. It's from 10 to 80%. If it's completely depleted, the time will vary depending upon that, and depending upon the brand, depending upon the car, this charging speed and charging time also varies completely. So this is a supercharger. So this is Tesla employs DC or AC, mostly DC only. So this is the cable which is used for charging its own vehicle. Connectors. So like now previously we saw how much hours it takes to charge, what is the charging speed, like that we saw. Connectors. What are the connectors which are used for connecting the vehicle for charging? Like different company employs different connectors, but they follow a standardized rules and regulations which is already set. So like some rules we should follow for like making the EV to be a better performance. First one is the most common type, SAE J177 connector type 1, which is mostly found in North America. It was the first continent to formally come up with a specification for EV charging. See, always American comes first. We don't know why, and we don't know how they background they will be clear. Not saying too much political, but just to like ensure that as like recently we saw Tesla also gave a interview that Tesla is big because of laser engineers like that. So this connector only supports a single phase charging. It's not for three phase. It's a single phase charging and can be found in North America and Japan. Like this is the most common type of charger. We can find it everywhere. Like mostly, most. This is the most employed one. find it everywhere. And next one is N-Pinch connector type 2. This is a type 1 connector, this is a type 2 connector. And previously, if you saw like the previous slides, I explained about like uh, fast charger employs type 2 connector. This is a type 2 connector. So within Europe, this is fine within the Europe, you would rarely encounter a type 1 charger. Instead, you would find only a type 2 charger, type 2 connector. Sorry for that one. This has been officially charging plug within Europe since 2013. Most households only support single phase AC charging. However, as this is the connector, it's not too powerful, can fit three phase electrical supplies also. So it supports three phase also, but mostly it's employed within like a single phase only. It's found mostly in Europe. And CCS1 and CCS2, which is nothing but combined charging system. So CCS1 and CCS2 from late 2010 for the next generation chargers combined of type 1 and type 2. As we saw previously, type 1 which is single phase, type 2 is for like single phase and three phase. It's a combination of both two. Chargers with a thick DC current connector. Previously we saw for ACs only. This is for DC also. So which is CCS1, which is nothing but combined charging system. One mostly found in North America, and combined charging system 2 is found mostly in Europe. The communication protocol changed to IP over mains, meaning that the charger conveys to Internet Protocol data. So these chargers, as you can see, this can connect with an EV. When connected, as you can like, if you have seen some videos, like, you have gone through some studies. Uh, if you connect a charger, it will indicate that charging level is what, from what time to what time it will get fully charged, and what is the percentage of starting charge. So this is achieved by like the pins. Like why this much pins are there means, like one is a control pin, pilot pin, they'll say like that, pilot pin. It's a more technical topic. I'll just brush it off like that. So this pilot pin and communication pins. Communication pins ensure that the connector is connected properly or not. If it's not connected properly, like the charging won't start. When it's connected properly, this uh, this communication pin will check with that, then it will give an input to the grid. Grid will acknowledge that, and it will start to give the powers to the cable. So some like type 1, type 2 didn't have, they'll mostly have CAN communication protocol. Like with CAN communication within a vehicle, it's the best option you can ever find. Like communication protocols, CAN communication, IP, is Internet Protocol. A car has requires those these type of things. But this connector, when it's connected properly, you will have a communication pin, you will have a supply pin which is plus minus. Other than that, a pin ensures whether it's locked or not. Another pin is for ground pin. So these much pins get into an like actively placed for a car to get charged properly. If the pin if it is not properly connected, then the car won't start to charge. That's why this communication here for CCS1 and CCS2, we can see that it has internet protocol data. So this combination connector means the car is adaptable in that it can take AC charge through a connector in the top up and a DC charge via the two combined connector part. I'll show you that. So this is a DCCC S1. If you see here, these two represents for DC supply, and this one represents for AC supply. If you see here, these three pins, AC supply and the ground. These two pins is responsible for connection and proper security. This is a like CCS1 EV connector, and this is a CCS2 EV connector. It is used in European countries. European standards completely differ from like American standards, but they combinedly come together for a common standard. Other than that, charging standards, depending upon the country, it will start to vary. So their own standards they're following for this one. And GBT connectors. Next one, referred to as UBIU national standards. One of the AC type charging, and other is for DC type charging. GBT AC connector can provide up to 7.4 kilowatt of power output within a single phase input. It represents the type 2 connector which is used in Europe. However, the cable configuration within the connector is different order, so that they are not incomparable. So that's not well. The GBT DC connector can deliver up to 237.5 kilowatt of power output, and is only DC fast charging protocol currently used in China. So this DC type connector is only used in China, whereas the AC type connector it's similar to the type 2 charger which is used in Europe, but the order is different, so that it's not comparable. So like this is GBT connector, and this is that was an AC connector. This is a DC connector. See, there are too much pins. Next one is Kademo EV connector. So it's a Japanese name. So the first attempted DC part was the Japanese Kademo, which is now used as the official standard for Japan. As I previously indicated, EV standards worldwide, worldwide they combinedly follow some set of standards. But when it comes to charging a connector, each country adapts its own style of charging. Why? Because every country has its own type of grid connection, electricity different, supply to the household varies, supply to the industries varies. So depending upon that one, they're adapting this EV connector. That's why for different country with some of the connector types may vary. Within North America, it is not widely used. Uh, apart from the Nissan Mitsubishi manufactured model. So for this model, they're using this, and it can charge up to 50 kilowatt and holds two pins side by side to carry the DC current. So it's a DC current. It takes DC supply. It uses the DC supply. As I previously indicated, CAN protocol is used here. This is used for the CP pin to communicate between the vehicle and the charging system. As it is said, when you connect the charger, when charging is connected properly, to ensure that there is a pin which activates. If it's connected properly, it sends a signal through a communication channel to the grid stating that here the charger, the connector is connected properly. You can start to give supply to the car. So it will start to give supply. Next is a Tesla connectors. So previously we saw like there will be an AC connector, there will be a DC connector, depending upon the country it will vary, and DC will vary, DC supply will vary, DC range will vary. Tesla connectors. So we'll now get into point like why Tesla is more popular compared to other EV brands, which are like coming like they're coming up, but moreover they're like why Tesla is more popular. Tesla, unlike other manufacturers, they have only one single connector. In one single connector, it can take both AC and DC supply. It's a very important thing here. You see, you can take both AC and DC supply. See, as you see here, it's a connector designed for AC and DC charging. Instead, they use the same physical connector. This is the connector, physical connector. The only difference is the Tesla Type 1 for North America, Tesla Type 2 is for Europe. Inside some like variations are there, like but the same. This is the only thing, same connector which is used for both AC and DC charging. Only Tesla vehicle can use this DC fast charger known as supercharger. So previously I said like what is charging, what is supercharger. Only Tesla cars can use a supercharger. So other cars cannot employ into it because the connector completely varies. As you can see, the design is also vary. Even though the design varies, it is within the standards of an EV, which is defined. That is AEQ 200. I'll get on to that last one. Like this is the SKJ Type 1 connector. So output current is in AC alternative current. what is like supply input, it's 120 volts or 240 volts, single phase only, and maximum output current varies for 120 volts it's 16 amps, and for 240 volts it's 80 amps, and maximum output current is from 1.92 kilowatts to 19.2 kilowatts. Charging level level 1, level 2. Primary countries are USA, Canada, and Japan. Next is for like type 2 connectors. Supply input is for 30 volts or 400 volts. Single phase, 400 volts for three phase. Maximum output current range is from 32 amps for 230 volts, 400 volts for 32 amps. Output power 7.6 kilovolts for 230 volts and 22 kilowatts for 400 volts. It's only used for level 2 charging, which is fast charging, and it's mostly used in Europe, United Kingdom, UK, Middle East, Africa, Australia, and CSS EV connector. So 480 volts, three phase, 500 maximum output current is 500 amps. Output power is 360 kilowatts. In DC 1000 volts, and it's a DC fast charging level 3, which is fast charging. It's used in USA, Canada, South Korea. This is for like uh, the same one, but it's used in Europe, United Kingdom. CCS combined charging system, and GPT connectors. For AC, it's 250 volts three phase, and for DC 440 volts. Maximum output current is 32 amps, and for DC it's 250 amps. Level 2 in for AC it's a level 2 charging level, and for DC it's level 3. Both are used in China only, not in other countries. And Kadamo EV connectors, which have the output current is direct current, it's DC type only. 400 amps output current you can get. Maximum output is 400 kilowatts, and primary condition is Japan. Tesla connectors, USA and Canada. Level 2 or level 3, single phase or three phase, AC or DC output current. So this is how a car which is getting connected with the connector for charging. I'll just skip on to that one. So now we'll get into like we saw globally, we'll now get into our own country, electric vehicle in India. So nowadays, you know that electric vehicle in India is getting more popular. Like as you can see now, previously like 4 years back or 5 years back, you can randomly find one car, but nowadays wherever you can go, you'll find more EVs in the like electric vehicle car in India. Most popular one car like Tata Nexon, MG Hector, mostly. Other than that, now we are gaining more popularity towards electric vehicle scooters, like two wheelers, Ather, Ola. More and more they're getting more popular towards that side. So EV market in India, like 1% EV market penetration is only up 1% of total sales. In our India, where only 1% of sales is there, EV market like it's based on like data analysis. Then based on data analysis, they're like saying that EV market is likely to be up to 50,000 crores by 2025. So that's a huge number which you have to see here. And 9 to 16% penetration by 2024 to 25. And 20% of the EV penetration is in e-auto category. 2% penetration in four wheelers like cars, like that. Key companies are Hyundai, Suzuki, Tata Motors, Toyota. These are the major companies playing in role for like EV marketing in India. So like state policies. So we can't just randomly go to a person or within our country saying like just buy an EV car, it's good, you'll get very good, it's like very less noise pollution, you can get everything greater power. If like you can't just go randomly to say that. Even if I was there, I won't buy a car like that. If someone comes randomly up to me and say like this is a good car, everything is that. So now governments are taking initiatives to make the people to like, get acknowledged like EV cars are good. So for that, these are the 10 states which have policies for electric vehicles. Like policies focuses on demand, supply, R&D, charging ecosystem, and technology base. Demand is nothing but incentive based on segments, vehicles, type rates. Supply, lower tariff on production, subsidies, and tax benefits. like if company starts to produce EV cars, they'll have lower tariffs, so which will like make make a company to shift towards an electric vehicle. And R&D grants and venture funds to research organizations and startups. So government is giving some funds if there is a startup better thing, and charging ecosystem supporting public infrastructure by providing land subsidy and other support. So even if you buy an EV car, if companies like studying that, let's like giving an EV car, next question comes with like where should I charge? I can't apply it in my home. I want a public place to charge. For that, government is giving a like giving a subsidy like or land. They even like giving a lease for land. They give a land on lease, like you can take a charging station here. You can put it here. You can put a company brand there. So it is giving like that company like a government of India is supporting, and it's like making us to push towards the EV. Financial support for growth of newer technologies and vehicle charging station. It supports even like if you're trying if a college student or something like that support like brings up a new technology, like we can make a charging like this, we can adopt a new technology, we can like more pursue towards it. Like India is supporting for that also. Here, this just indicates that which of these is supported by which of these states. So, for an example, Delhi supports only for demand charging ecosystem and technology. It does not support for R&D and lower tariff productions. Uttar Pradesh supports for all of these. In Tamil Nadu, for financial support for technology, they still not supporting. I like we don't know why it's happening towards that one. Other than that, they're supporting for others. Next, this is a Tata car, the most popular car you would have seen on every road. You can find it nowadays like everywhere. Tata is like the guy who like is making everyone like he's gaining popularity by just showcasing it. So EV market growth. This is also an analysis only. It's based on data, previous data. How an AI works. It gets a data, it reads the data based on that assumption, mathematical calculation, it gives an output. Same kind of thing they did for a market analysis up to 2030. And here, as you can see that two-wheelers will will get more sales by the end of year 2030. As you can see here, green color indicates for two-wheelers and slight green, like my green is for like three-wheelers, uh, buses, car commercials, and cars in private. So their guess, like it's a global market kind of thing. Their guess is that this is within India. I like to suggest say that this is within India. Within India, they are guessing that two-wheelers will gain more in sales by the end of 2030. So as you can see that the numbers are increasing from 20 to 25, 26 to 30 is increasing, but they're saying that the cars in private will slightly only gain margin, but not much of a difference. We don't know. If if we have some kind of subsidy towards a customer, we may switch towards a car because two-wheelers are now more getting more and more popularity. Next is like market size for EV components. Now now I just spoke about the market for the whole EV car. Now for EV component. So EV component for electric motors, rough guess is about like by the end of 2025, electric vehicle value chain in India is expected to reach about $4.8 billion, which is a huge game. It's a huge market. If you see, like if you're look at the production side and industry is running, it's a huge thing. And moreover, like for a single component, it doesn't mean like single industry should support. It is made up of many small industries contributing to a bigger product. That bigger product combination of those bigger products supports to a main head. So like that, even if a single like bigger industry starts to boom, it's uh, the industry which is contributing towards it also will start to boom. So from there, like analysis, they're saying like for electric motors, it will gain up to 1.23 billion dollars, and for batteries 1.6 billion dollars. Power electronics is 1.47 billion dollars. Charging stations 0.230 billion dollars. So this is a estimation for all those things like two-wheeler, three-wheeler, cars, buses, and they're saying that 60% to 67% will be the passenger car segment share in the battery market in 2025, and demand will also increase to 15.6 million kilowatt. So, if any of you guys are like in share markets or like I like to invest in shares, this is a great opportunity if you want to invest. See, like it is an upcoming EV industry. Look on to its data. If you get, if you would, you can at least get a good margin with it. Now, for the total EV market sales forecast in with respect to hybrid and electric vehicle global data. This is in global data. Previously, we saw for Indian market. This for global market up to 2027. So they say like mild hybrid electric vehicle we can see in production up to it is like it has a huge rise. So a mild hybrid electric vehicle, as I previously said, it's an hybrid vehicle. It runs on fuel only, but it supports the engine for higher performance. So most of them are shifting towards that side. It's just a guess. We don't know how the original market works. We don't know how it will rise or it will get down. If any COVID again comes, it might go up or down. We just don't know how it works. So for battery electric vehicle, at the end of 2027, we can say up to like uh, the the production market is very less, and for plug-in hybrid vehicle, it's also there. But it's most likely to suggest that for mild hybrid electric vehicle, for mild hybrid electric vehicle, the production value will increase like 36% in the year of 2027. Now, we said about what is an EV, what are the uses of EV, how government helps us, like what are the charging, what are the connectors, no challenges. So whatever goes up must come down. For like that challenges. Even though government helps in getting us into an EV, even though EV has more advantages, it's more eco-friendly, environmental friendly, too much savings are there. But what is the main challenge that why we are not moving shifting towards that EV? So what are the challenges of Indian EV industry is that on-road prices of electric vehicle is very high. So if you see here, there is a like a graph which says that purchase price is very high. We are a customer. So if the price is less, we can just get into that market. If the price is high and it has too much problem, we won't get into that much. That one challenge is on-road price of electric vehicle is very high. Inadequate charging infrastructure. There is very poor charging structure in India. I'm not even saying less. It's very poor. Reliance on battery imports. I'll get on to the topic. Range anxiety among our customers. Inadequate electricity supply in parts of India. Lack of quality maintenance and repair options. Changing the mindset of consumer that is adopting to a new technology. It's like suddenly getting into an EV. Everyone knows like combustible engines. Yeah, like if you are a bike guy or car guy, you'll get a knowledge about what is an engine, how it works. You sometimes should have like deassembled it, played sometimes with it. But suddenly, if you're getting into an EV, it's more into electricity, more chemical. Some battery has chemical and engine. One mistake can blow up the whole thing. So first is like high purchase cost. The price variation of electric cars is from 9.5 lakhs for an Mahindra E Vertino up to 24 lakhs for Hyundai Kone. As of the price of 2022, now 24 its price is around 23 lakhs. I think. So for this range, if you really want to go for like even if I am a customer, if I say this, I'll say like 24 lakhs for an EV car. For the 24 lakhs, I can go for a Mahindra car, which is having a good, it looks like a muscle car. Price ranges from 10 to 17 lakhs only. So next is a Scorpio. It's a muscle car, like kind of thing. We can go for price range also ranges from 12 to 17 lakhs only. MG Hector, 13 to 22 lakhs. So as I'm saying, why I'm saying this because I just want to give 24 lakhs for an EV car, which is very high. Then I have to take care of that charging expenses also, which is also very high. Instead of that, I can move to a lesser version where I can consume money. So that's why like EV adaptation is different. If the pricing comes down to certain amount, then customers may think about it, but not like they'll buy it. I'm not saying they'll buy it, but they'll just think about it. Next is range anxiety. The travel range. Range anxiety is nothing but if I'm charging how much kilometer it will travel. So on a full charge, it will travel up to 181 kilometers for Mahindra and 450 kilometers for Hyundai Kona. So which is very less. If I take a fuel vehicle, I can go like anything. I can just have to refuel it, and full the tank, and I get to travel. If this is a 452 kilometers, can travel much. If it stops in a mid dead center, you can't find a charging station. It's then gone. You just have to drop the vehicle, take a lift, go home. It's very bad. So now lack of charging infrastructure. As I said, there are at present 250 public charging stations in India. All over India, which is having very great population, it is having only 250 public charging stations, which is very less. For 1 million EV per city in India, an estimated number of 2 million charging stations will be required, mix of both fast and slow. So it is a high margin only. Still, we have to concentrate on that one. That's why, like in India, the EV is not gaining popularity. Main problem is of charging infrastructure only. Main is charging infrastructure, charging challenge. So, so Mahindra E-Verti, I'll just take an like example, live example only. It takes about 1.5 hours to charge the vehicle with fast charging, and congestion at the charging station is another challenge. Even though if you're building a charging infrastructure, we know like we are not ready to stand in line and wait for 1 hour and get a charge and take a drive. That's too much. So there is another main problem. Like we have to wait for if another person puts a charge, we have to wait until it gets fully charged. So it's a main problem. For this problem, Hyundai is coming up with another plan how to like overcome these issues. They're planning to implement the charging infrastructure like nothing. They're just going on to it. Service and maintenance. Still, the repair and accessory availability of the electric vehicle is a nascent stage only, and only when the market scales up, such system is developed. As of now, we know that there are too much parts and too much. We have too much parts and data for combustible engine only. That's IC engine. For EV, we don't have that much part because there's no much awareness towards it. That's it. And battery technology. The decreasing per kilowatt cost of batteries proceeding at the same time. However, India relies on the imports of components. That's a major thing you have to note that. However, India relies on the imports of components and major loan how is Dubai. So India is like importing components for batteries. It's not making batteries here. It's just importing components. That's why battery technology cost is very high. If it starts an innovation within our country, it might scale down a bit, but we don't know how much it will scale down. Battery manufacturing capabilities. Market experts estimate that EV battery industry in India has a potential of $300 billion by 2030. Currently, there are few manufacturers, ISRO, BAIL, joint efforts, Amara Raj, HBL, Canada Electric, Excite, but battery manufacturers worldwide are aiming in India. So we have a potential of $300 billion market within India for battery manufacturing technology, but we are not having that much company which is coming forward to like implement those things and they're ready to start up with the new things. So next is power management. India is a power deficit country. For 1 million EVs, assuming an average battery capacity of 30 kilowatts, for Hyundai Kona it's 64 kilowatts. India requires around 15 million units of electricity per day, which is very huge. Even though we have sufficient amount of electricity, we are daily facing and power surge issues every day. So if this comes into play, to to be in, put in simple words, we'll face a power surge for every 1 hour. First, you have to increase the uh, power generating capacity. Based on that capacity only, then we have to focus it. So it's a related thing. It's a mesh of problems. If you start with if you try to pull one net of the entire mesh, everything will start to fall apart. You have to concentrate on one thing at a time. Existing huge hydrocarbon waste automobile industry. As of now, huge investment of industries existing in terms of manufacturing, sourcing, distribution, service of maintenance, which is combustible engines. There are very huge amount, very big companies, very big, what you can say, very big governments and all playing for combustible engines. Suddenly making them to shift from combustible engine to an EV is an it's a literally impossible task. I can put it in that term. It's a literally impossible task. Suddenly changing will more will go into politics kind of things. So it's there also a problem. Lifetime cost and disposable cost. Then suddenly unlike over the resale value and the battery replacement cost after its limited range. So like nothing but throwing it off. We don't know where to throw it. Generally, if a battery goes in our household, every day normal battery goes, we just throw it in the dustbin, which is very wrong. But we used to do that. So if a car goes, if it's a combustible engine car, you can just go to a scrapyard, just throw that off, you can come out, you can get an amount. But that doesn't work for an EV car because an EV car parts is like how to say that the batteries are harmful to the environment. We can't just throw it like that. And we still don't know what is the resale value. Whatever the electrical components used within an EV car is more costly. If you take and resell it, we don't know what is the resale cost in EV. Next is charging station challenges. As I previously mentioned, there is very less charging stations in India. So I just show it here. So like Mumbai, despite being one of the mega cities, the charging facilities still have not been level. It is not up to the mark. See, more than 100, 50 to 100, less than 50. As you can see here, in Kolkata, it's less than 50 charging are in entire Kolkata. In Delhi, it's more than 100. We don't know the exact numbers. And in Mumbai, it's 50 to 100. In Bangalore, 50 to 100. In Tamil Nadu, they have started it, but we don't know the exact amount what is happening there. And charging levels, as I said, like we need more electricity to like support for that. As per industry analysis, increase of EVs by 2030 will shoot up their 100 trillion watt, which is very huge. So we have to first face the issue over there. We have to resolve the issue there, and then come back to it, then start to resolve one by one issues. Then what are the startups? So major startups are in India are Ether Energy, which is major funding by Hero Motorcorp, and you, it's a bicycle company. You can just find this most in Mysore. Mysore, yeah, it's in Mysore only. Bajaj Auto invested about 8 million in how much is 19. Ola electricity mobility, Ola bikes now they are gaining very like their popularity when they first entered the market. Nowadays it's very bad due to their battery issues and other things. Next is battery. It's a Jaipur based company. Former Tata Motor President Gajendra Chandra invested an undisclosed amount and the company is like 2020 they said, but we don't know. Like Smart E Trio focuses on electric car. Smart E focuses on e-rickshaw. I think you have seen the Smart E. There's an three-wheeler auto which comes in completely green color. Like somewhere you could have just seen this one. And major startups around the globe. London has about 37 startups. Los Angeles has about 29 startups. And Silicon Valley has 28 startups, New York City has 21 startups, and Amsterdam has 21 startups. So EV manufacturers in India are Mahindra Electric, Hyundai, Lohia, BYD, Ola, and Tata Motors, Ashok Leyland, 22 Motors, MG Motor, and Ether Energy. These are the like, major big shops which are playing in India for EV manufacturing. So that's all for like today. I like to close this session. If you have any questions, please shoot up the comments. I'm ready to answer.
Dear participants, if you have any queries, you can post it in the chat box or you can unmute yourself and ask the questions. Wonderful presentation, Kabilan.
Thank you, ma'am.
We got a very good knowledge on the charging levels, charging speed, the challenges we face in our country regarding these e-vehicles. It was very knowledgeable, clear, and excellent. On behalf of our department, Triple Department, SA Engineering College, I extend a hearty vote of thanks to Mr. Kabilan who spared his time to grace the occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. Thank you very much, Kabilan.
Thank you so much. Thanks for this opportunity. I would like to thank everyone for giving me this opportunity, especially in college and like Kamala sir. Everyone. Thank you so much for this opportunity. Thank you, guys.
I wanted to take a moment to express our sincere gratitude for all the participants in this Exodus 4.24 event. Thank you, participants. A feedback link is posted. Kindly fill the feedback before leaving the session. Thank you all.